Hello everyone. Today we're going to talk about some basic concepts of networking, specifically routing and switching, which are the most common topics you'll encounter at the beginner level. In networking, routing and transmission must meet certain standards. In this context, today we're discussing the Ethernet protocol, which defines the standards for data frames transmitted within our network. Understanding the Ethernet protocol essentially means understanding our network. The second layer, sometimes referred to as the data link layer, is its foundation. In this context, switches are the main devices that enable our layer 2 communication. In today's lesson, we'll discuss our network protocol and the types of MAC addresses, as well as the working process and mechanism of layer 2 switches and related concepts. Today, we will describe the types of Ethernet networks, including how to distinguish MAC addresses and the operation process of layer 2 switches. In addition to our own, how is the MAC address table constructed and generated? Now, let's talk about some basic knowledge of Ethernet protocols. First, we say that the Ethernet network, the Ethernet protocol, is actually the most commonly used communication protocol standard in our local area networks today. It defines the types of cables in our local area networks and the methods of signal processing. Which Ethernet is it? It is a broadcast network constructed based on the technology of carrier sense multiple access with collision detection, CSMA-CD. Looking at the early Ethernet, it was all within a small collision domain. Now it is a broadcast network established based on the CSMA-CD mechanism, but these collisions limit our network. This affects its performance. In the early days, if we talk about Ethernet devices such as hubs, they operate at the physical layer. In this context, there was no way to confine collisions to a specific range, which limited the improvement of our network performance. For example, if we are all in the same local area network, only one person can transmit at a time, while the others can only receive and have to wait here. They cannot speak. Simultaneous sending and receiving is not possible. Only one device can transmit, which results in very slow efficiency. Later on, with our current switching network, we have switches. These work at the layer 2 switch level, which can isolate collision domains, within a specific range, right? I separate each collision domain, with each interface being a collision domain. On the other hand, all devices are within one collision domain. So each interface being a collision domain allows for simultaneous receiving and sending, thus improving overall efficiency. Moreover, it also replaced hubs. Switches have already become a mainstream Ethernet device for us. However, we say that switches do not limit the broadcast traffic in the network, which can also affect Ethernet performance, because at the same time, if I have a PC and I send a broadcast, the switch will perform an action called flooding, just like a flood. It sends a copy from all my remaining interfaces. Now, if every device sends this broadcast, our switch actually does not effectively isolate it, unable to effectively isolate it. Here, we mentioned a collision domain earlier. That's why. What is a collision domain? A collision domain refers to a group where I connect to the same device, and all these nodes within this collision domain all compete for the same bandwidth, meaning we all use this same bandwidth to compete. Why? Each node sends packets such as unicast, multicast, or broadcast, which can actually be received by other nodes. Even if I send a unicast, because we are in a collision domain, everyone else can receive my unicast, and there's nothing I can do about it. In a one-to-one transmission, within a shared network, he used a technology called CSMA-CD to solve the problem of preventing data collisions when everyone tries to send data at the same time. How is this problem solved? In this process, I will go through several steps. Why? First, I will listen before transmitting, which means I will first check if anyone is transmitting data on the network. If no one is, then I will transmit. However, during this process, it's possible that both of us are listening at the same time. If we both think the link is free, we might transmit simultaneously, which could cause problems. Therefore, the second step is to listen while transmitting, meaning I will continue to listen as I transmit. So, if in this situation, for example, we both happen to transmit at the same time, what should we do? In this case, if we detect that someone else is also using the link while we are listening and transmitting, we will stop transmitting. Whoever detects it first will be the one to realize that there are others on the link. Then they will stop first, and after stopping, they will wait for a random delay, which is calculated based on their own algorithm. In this situation, for example, if it's 10 seconds, right? After waiting for 10 seconds, they will attempt to transmit again. Delayed retransmission now during this process, but here we say that CSMA-CD is actually not that perfect, because waiting for 10 seconds doesn't necessarily mean that I can transmit after 10 seconds. After 10 seconds, it still needs to check if anyone is transmitting in the network. If it detects someone, what will it do? It will generate another random number. Is it possible that this random number, for example, is 20 seconds? After 20 seconds, it will check again if anyone is using the network. It's possible that I am using it because there is no first come, first served mechanism. So in this situation, it will still affect our efficiency. Now, if during this process, our current switch, all of its interfaces have independent sending and receiving. Each of these is a collision domain. This is a collision domain. This is a collision domain. This is a collision domain. And this is a collision domain. So they all belong to different collision domains. Therefore, when connecting computers through our switch interfaces to enter our network, at this time no changes will occur, and there will be no impact. This is our collision domain. Besides the collision domain, we also mentioned earlier that our switch has a downside, which is that, it cannot handle the broadcast domain. It cannot provide good isolation for it, because in this context, when the switch receives our broadcast, it will flood the broadcast packet throughout its entire access range, which we can refer to as the Layer 2 broadcast domain. It can also simply be called the broadcast domain. This is the propagation range of our broadcast packet, and within the same broadcast domain, all computers can receive this broadcast data packet. In our early Ethernet environment, if multiple devices are connected to the same medium, meaning they are connected to the same device, such as a hub, they share a single link, the broadcast packet sent by a device can be received by all other devices. Besides this, in the current network, a switch will also forward the broadcast packet to all its remaining interfaces. Therefore, all interfaces connected to the switch actually belong to a single broadcast domain, meaning they are all within the same broadcast domain. And this is the extent of my propagation range. So what about in the future? When we send a broadcast in the future, it actually has a special address. For example, in IP, the global broadcast address is 255.255.255.255. Besides this, don't we also need to encapsulate the Layer 2 MAC address? The entire FFF during this process, we say this is our broadcast MAC address based on this, right? We use it to determine whether it is a broadcast. When the switch receives a broadcast, it will help you to flood it. Besides this, when our computer is going to receive it in the future, actually our computer needs to have a network card, which means it is responsible for connecting our network devices. For example, when I connect to other switches, other routers, other computers, and other devices to the external network, this is a crucial component. Our network interface is also called a network port or a network card, right? They are the same. Each network port must have a network card. When a computer or a switch calculates or processes data, it forwards the data through this network card. Now, in this context, the network card used by each network interface of our switch is an Ethernet card, which is the Ethernet network protocol we currently use. These are some basic concepts of Ethernet, including network cards and concepts of collision domains and broadcast domains. If you want to learn Huawei certification technology or want to obtain the Huawei certification question bank, please send me a private message, or you can leave more comments under our video for technical exchanges.